going to be talking about stoichiometry now. And stoichiometry is just the study of the relationship between relative amounts of substances. So first we're going to look at the stoichiometry in a compound and see how much of the elements make up that compound. And then next we'll be looking at stoichiometry comparing reactants to products. So when we look at a compound, the formula tells us exactly how many atoms we have using the subscript. So here in our example it says C2H6. So we know that we have 2 carbon atoms. Ooh, that was way off. 2 carbon atoms and 6 hydrogen atoms, just by looking at the formula. Well, I can change the wording a little bit and say I have 1 mole of C2H. If I have 1 mole of C2H6, then I have 2 moles of carbon and 6 moles of hydrogen. So I'm still looking at these subscripts, but I'm using the term mole now instead of molecule and atoms. So I'm going to make a conversion factor using that formula for the compound. So if I have 1 mole of C2H6, then that means I have 2 moles of carbon. Okay, if I have 1 mole of C2H6, then I have 6 moles of hydrogen. So I set them equal to each other, and I'm just making my own conversion factor for this formula. So in this question it says, find the number of moles of oxygen and 1.7 moles of calcium carbonate. Okay, so to be able to do that, I have to get oxygen by itself. So that's why we make that conversion factor. So again, if I have 1 mole of the compound calcium carbonate, then I have 3 moles of oxygen. And all I'm doing is looking at that formula to get the 3. So if I have a total of 1.7 moles of my compound, now I just set it up to where the moles of the compound cancel and I get oxygen all by itself right here. So if I have 1.7 moles of calcium carbonate, that means I have 5.1 moles of oxygen. So let's try some examples. So it says calculate the number of grams of sodium and 1 gram of sodium phosphate. I'm actually going to come over here and do that. Okay, so if I have 1 gram of sodium phosphate, we want to know how many grams of sodium do we have. Okay, so first thing I have to do is I have to get it in moles. I can't make that conversion factor with moles of my compound to moles of my element and then use it with grams. So I have to change this first part to grams. To moles. So we're going grams to moles first. So I look up the molar mass of sodium phosphate. So I have 3 sodium. Sodium weighs 22.99. 1 phosphorus weighs 30.97. And then 4 oxygen. Oxygen weighs 16. So add those up. It's 163.97 grams per mole. 1 mole. Okay, so now that I have this in moles, now I can use that conversion factor that we've been talking about. So let's make that down here. So if I have 1 mole of sodium phosphate, and we're going to sodium, then I have 3 moles of sodium. So that's how we're going to get sodium all by itself. Okay, so I'm going to add that in here. I want moles of sodium phosphate to cancel, so I'm going to put it in the bottom. 1 mole sodium phosphate. 3 moles of sodium. Okay, now we have sodium all by itself, but the question is asking for grams. So if I went ahead and solved this, I would have moles of sodium, but I need one more step to get it to grams. Okay, so now we're going to use the molar mass of sodium to go from moles to grams. So 1 mole of sodium is equal to 22.99 grams of sodium. So I just looked up that number on the periodic table. Okay, and that gives me 0.421 grams of sodium. So out of that 1 gram of sodium phosphate, 0.421 grams of it is sodium. So we're going to do that for every element in sodium phosphate. Next, we're going to do it for oxygen, and then we can add up how much phosphorus is there. Okay, so again, we're going to start with 1 gram sodium phosphate. Okay, and again, we cannot go straight to that mole to mole ratio, that conversion factor we're making, until we have our compound in moles. So we're going to use the molar mass of sodium phosphate to convert it to moles. So we already looked it up. It was 163.97 grams of sodium phosphate per 1 mole. So always 1 mole with molar mass. So grams of sodium phosphate cancel. Okay, now let's come down here and make our conversion factor. So if I have 1 mole of sodium phosphate, and how many moles of oxygen do I have? I have 4 moles of oxygen. So there's our mole to mole ratio that we can make. Okay, now I'm going to put that in up here. So I want moles of sodium phosphate to cancel, so I'm going to put that in the bottom. So make sure you're writing these compounds and these elements out so you don't get confused. So sodium phosphate is going to cancel. Now I have I have moles left of oxygen, but I want grams. So we're going to do one more step, go from moles to grams using molar mass of oxygen. The molar mass of oxygen is 16 per 1 mole. So moles of oxygen cancel. And that gives me 0.390 grams of oxygen. So 0.390 grams in my 1 gram sample is oxygen. Okay, now we're going to figure out how much phosphorus we have. So if we know how much sodium and how much oxygen we have, all we have to do is subtract those numbers. So if I have a total 1 gram for my compound, and if I subtract out the 0.421 from sodium and the 0.390 from phosphorus, that leaves me with 0.189 grams. Wait, I think I said that wrong. 0.421 from sodium, 0.390 from oxygen. That leaves me with 0.198 grams of phosphorus. So now we know exactly how much each element makes up for in our 1 gram of sodium phosphate.